Hello everyone. Sensitivity analysis of transfer function of closed loop system. This means parameter of a control system may have a tendency to vary due to changing environment conditions, and this variation in parameters affects the desired performance of a control system. So there are many disturbances which occurs. So due to these external or surrounding disturbances, control system have the tendency to vary due to these variations. So the parameter of any control system may get vary due to these surrounding disturbances. The use of feedback in a control system reduces the effect of parameter variations, and we have already seen the effect, or you can say the advantage of feedback system, or rather we will say it feedback control system. So this feedback control system may give you the advantage to reduce the effect of parameter variation. So what we are saying, every practical system will have the surrounding disturbance for sure, and due to these surrounding disturbances your parameter of control system will get vary. But the feedback system or feedback control system gives you an upper edge towards reducing the parameter variation in your output of system on the whole closed loop control system. So the term sensitivity in relation to the control system gives an assessment of system performance as affected due to parameter variation. So here the sensitivity term gives you kind of an assessment of the system performance as affected due to parameter variation. So this is the you can say the term sensitivity is defined. So it gives you an assessment of the system performance as affected due to the parameter variation. So let's, and sensitivity, we'll see what will be the sensitivity or what will be the effect of transfer function variation in open loop control system, as well as function parameter variation in closed loop control system with respect to the different parameter. So we'll start with the effect of transfer function parameter variation in an open loop control system. Let's take, this is your an open loop system. This is, let's assume this is input RS and corresponding output is CS, and this is your transfer function, open loop transfer function. This is your open loop system. So in the case of open loop system, the overall transfer function is, let's say I'm taking the overall transfer function MS. So the transfer function of this system MS is nothing but CS over RS, and that is equals to nothing but GS. So the open loop transfer function, it is pretty much clear that open loop transfer function is nothing but GS. Now let's say a slight change. Now what I'm doing, I'm just bringing some slight change, del GS. Del is a small value, so del GS is in the transfer function, GS changes. So this much slight change occurs in GS. So the total transfer function now will become, instead of GS only, so it will become GS over LGS. So this change, let's say it happens due to any parameter variation in GS, and due to this parameter variation, now your open loop transfer function will become GS plus del GS. And if this is your transfer function, so what will be the change in the output? Change in output, let's say I'm denoting it with a slight change in output, del CS. So the new output of the system will become CS plus del CS, and that will be equals to, and this will be equals to plus del GS into RS. So if you can see from here this relation, so my output CS is nothing but GS into RS when there is no parameter variation, and after parameter variation my output CS plus del CS will become equals to GS plus del GS into RS, and I'm doing it further simplification. So this will become GS RS plus del GS into RS, and from here, as we know, CS is nothing but GS into RS. From this, CS is nothing but GS into RS. So your del GS will become, if we'll just compare it from here, del CS will become equals to del GS into RS. From this relation, if this much is your CS, so this is your del CS. So this equation gives the corresponding change in the output with reference to change in del GS in the transfer function GS of an open loop system. So please keep this in mind, that change in the output in open loop transfer function is equals to del CS into RS. Now let's check what will be the effect of forward path transfer function parameter variation in a closed loop control system. Now we'll see the effect of forward path transfer function parameter variation in a closed loop control system. Let's draw the block diagram of the closed loop control system. First, let's say this is your input RS, output CS, HS is your feedback, and GS is your forward path transfer function. So this is your forward path transfer function, this is your feedback, output, and input. So in case of closed loop system, the overall transfer function, now let's find out the closed loop transfer function MS, which is nothing but the CS over RS, and that will be equals to, as we know, it is nothing but GS over 1 plus GS HS. Your feedback is negative. Now let's again a slight change, say a slight change the effect of forward path transfer function. So we have seen the block diagram of the closed loop system. Now the closed loop transfer function MS for the taken block diagram is nothing but GS over 1 plus GS HS, and let's say slight change del GS in the forward path transfer function, which is nothing but GS occurs, and so the forward path transfer function becomes, instead of GS, now it will become GS plus del GS. And let the corresponding change in the output with respect to this, the corresponding change in output, let's say del CS. The new output of the system is now, instead of CS, it will be CS plus del CS, and that will be equals to GS plus del GS over 1 plus GS plus del GS into HS and into RS. So instead of GS, I have just replaced GS with GS plus del GS. So my output becomes equals to, because your MS is nothing but S over RS. So from here I have found out CS is nothing but this into RS. So further doing the simplification over here, plus del GS over 1 plus GS HS plus del GS and HS into RS. As a change in GS is considered slight, so we can say the del GS is very much less than the actual GS, and thus the term del GS into HS can be neglected. So this term can be neglected. Just for simplification, we are doing this. By doing so, my CS plus del CS will be equals to GS plus del GS divided by 1 plus GS into RS. So here I have neglected this term. Further simplification of this will give me CS plus del CS is equals to GS over 1 plus GS HS into RS and plus del GS over 1 plus GS HS into RS. So I have just simplified this term over here, and now if we'll compare it, this term, the first term, is nothing but the actual CS. If we'll compare it from here, so this is nothing but the CS. So from here I can conclude that del CS is nothing but equals to del GS over 1 plus GS HS into RS. So this much variation will happen in the output if a slight variation in part transfer function variation happens. This is for closed loop, and just now we have seen for the open loop also, that I'm writing again the final one. In the open loop it was del CS is equals to del GS into RS. So this was for an open loop system. So variation in the output in open loop and variation in the output in closed loop. So from here we can see, or we can conclude it comparing these two. The variation in the output of closed loop system gets reduced by a factor 1 plus GSHS as compared to the open loop, because in open loop the output variation is equals to del GS into RS, whereas the same closed loop system with the feedback HS gives you, or the variation in the forward transfer function or the output gets reduced by a factor 1 plus GSHS. So from here we can conclude that yes, a feedback in a control system reduces the effect of parameter variation. So by looking these two equations for closed loop and the open loop, in the variation in the output with respect to a slight change in the variation in the forward transfer function, in closed loop system the variation in the output is lesser as compared to your open loop transfer function. We have seen that how the feedback system reduces the sensitivity of the in the output variation due to the parameter variation in the forward path transfer function. Now the change in the variable due to variation in the parameters of a control system is expressed in terms of sensitivity. Again, I'm repeating, the change in a variable due to variations in the parameter of a control system is expressed in terms of we are going to see now. Okay, let's check now the variable. Let the variable in control system which changes its value be a. So we are talking any variable in a control system, variable in a control system which changes its value be a. Let's say any variable changes its value such as output, and this change is considered due to the parameter variation of k such as gain or feedback. So the variable, any variable change in the control system changes its value a as output. So this change is as output, and this happening due to parameter variation of element k as gain or feedback. So what we are saying, let's say a parameter variations happen in any element by k. So this is variation, and because of this variation, so your output gets changed by value a. So we can express sensitivity is equals to percentage change in a over percentage change in k. So how much k is changing and how much a is changing, ratio of this is nothing but the sensitivity is written as sensitivity a due to k is nothing but change in a and change in partial change in k. The notation, this notation denotes sensitivity of variable a with respect to parameter k. So this notation over here, this one denotes the sensitivity of variable a with respect to parameter, and it is always preferable that this factor should be minimum. So this should be as minimum as possible. So the variation in a with respect to any parameter, let's say here we have taken k, should be as minimum as possible. If it is minimum, so we can say for any system that your system is less sensitive towards any variation in parameters. Now let's check the sensitivity of overall transfer function ms with respect to forward path transfer function gs. Sensitivity of overall transfer function ms with respect to forward path transfer function gs. The sensitivity function for overall transfer function ms with respect to variation in gs is written as, just now we have seen the mathematical expression, sensitivity of overall transfer function m with respect to g, and this will be equals to partial change in ms with respect to ms over partial change in gs with respect to gs, and this can be further simplified this over ms into del ms over del gs. So let's take the first case in this open loop control system. For the open loop control system, as we have taken first block diagram, the overall transfer function ms for open loop system, ms is nothing but cs over rs, which is nothing but gs. So from here ms over gs will be equals to, so from this relation ms over gs is nothing but 1, and differentiating ms with respect to gs, this one, differentiating ms with respect to gs, del ms over del gs, that will give me 1. So substituting these two value in this equation, so for open loop transfer function, the sensitivity of transfer function m with respect to g will be equals to 1. This is for an open loop control system, because ms over gs is also 1 and del ms over del gs is also equals to 1. Now let's take the second case, that is closed loop control system. In this we are going to take the second case, that is closed loop controls. For the closed loop control system, we have seen the total transfer function with forward path transfer function gs and feedback hs will become equals to gs over 1 plus gs in. So let's quickly finish it. So closed loop control system sensitivity, to find out, we have taken the closed loop transfer function over here ms, and let's find out del ms over, and this will be equals to, let's differentiate the ms with respect to gs, so it will be 1 plus gs hs over here. First I have taken this term over here, and differentiation of this gs with respect to gs, so this will become equals to 1, so 1 over here, gs and differentiation of 1 plus gs hs with respect to gs will give the hs, and divided by plus gs hs and square of this, and further this can be right, del ms over del gs is equals to 1 upon 1 plus gs hs square of this, because this will get cancelled. So substituting these value to find out the sensitivity of m with respect to g, will get, this is nothing but gs over ms into del ms over del gs, and that will be equals to gs over, putting the value of ms over here, ms is gs over 1 plus gs hs, and putting the value of this from here, 1 upon 1 plus gs hs and square of this. So finally we get the sensitivity of m with respect to g for closed loop system is 1 upon 1 plus gs hs. So this is for closed loop, while for open loop sensitivity of m with respect to g was 1. So it is clear that the sensitivities get reduced by factor 1 upon 1 plus gs hs. With respect to sensitivity, there is one more topic left, that is sensitivity of overload transfer function with respect to feedback path. This we have seen for the forward path. Now let's quickly check the sensitivity of overload transfer function m with respect to feedback h, and that will be equals to del ms by ms and del hs by hs. So this can be right, hs over ms into del ms over del hs. So the overall transfer function ms for closed loop system we have already known. Ms is nothing but gs over 1 plus gs hs. So differentiating with respect to h, differentiating ms with respect to hs, partial differentiation will give us gs square upon 1 plus gs hs square. Please verify by yourself, you will get this much. And now the putting value, I'll get the variation gs hs. So this is the sensitivity of overall transfer function with respect to feedback. So now from this equation it is concluded that a closed loop control system is more sensitive. A closed control system is more sensitive than the variation in forward path parameter. Therefore, specification of feedback element in a closed loop control system should be more rigid as compared to that of forward path element. Thank you.